Right, okay. Let's see if we can just finish out this tokenizer now, shall we? So, I think we've written it. I think it works. It's not really been tested, so let's test it. Let's make a little UI, okay? And we can build on this UI, I think, as we go along, so that we can add error handling, the parser output, syntax tree, etc. But let's start simple. We'll start with a window. Now we're going to need a little area to write our code. So let's just start with something simple. I have a little surprise in store. I might give it a little taste at the end of it, we'll see. Anyway, we'll start with just a little text area, and this is going to be our source code. Okay, so in here we're going to write our source code. Let's make this window a little bit bigger, a bit more space. Bit of space there. Okay, looks good to me. And let's lock that in position, and we'll call it source code. Right, we need a list box, so when we type in our source code, we'll hit a button that says tokenize, and then we'll have a list box that will show us the tokens. So in actual fact, we probably need a bit more space than that. That's going to be a bit annoying. How about we put the list box, let's make it wider. Let's do it like that. Let's make this even wider. Let's go for 900 wide. That's 600 deep. So we've got plenty of space for source code, and we will have the list box underneath. So go to library, find the list box, and just line it up nice and neat. Don't know how many columns we're going to need yet. Just make it wide. And we need a couple of buttons. We're going to have one which is tokenize, and we're going to have one which is I don't know, clear. So let's just name them. So that's button clear, and we'll call this one button tokenize. Okay, we'll lock them to the bottom corner so they don't move if we resize the window, like so. Let's lock that to the bottom and that. We'll keep the source code, actually we'll keep the source code that size, and the token box will grow as we stretch the window. Yeah, that should work. So just check. Yep, that's good to me. Okay, so how many columns do we need? What do we want to show? Well, let's think about this. We do initial, we'll give it a header so we can see the titles of the columns. And we're going to want line number. We want the character index that it starts at. So we'll just call that start, maybe. Another tab. We want type, so the actual token type, and let's put the lexeme in as well. That's probably sufficient. 4 columns. Okay, so we'll tell it we've got 4 columns. We don't want them all the same width because the line and the start number are going to be really narrow. So how about we fix them at 50 pixels a piece, and we will have the lexeme twice as big as the type. That's probably about right. Pretty wide for a lexeme, but I guess if you've got a string token, that could be quite long. Okay, that'll do. So how do we make this do something? Well, we need to give it a name. So we'll call that this box tokens. And let's do the clear button first. Double click it, add an action. What happens when you clear it? Well, let's just do listbox tokens dot remove. all rows. That'll clear it out. And source code text equals empty. Okay, so that'll clear it out. When we click the tokenize button, we're going to tokenize what's in the source code. So we need a tokenizer instance. So let's add that as a property to the window. We'll call it tokenizer. And it is of type Objo Tokenizer. Keep it public for the moment. And what we'll do is, rather than reinitialize the tokenizer every time we push the tokenizer button, we will add an event to the window so that when the window opens for the first time, we will do self.tokenizer equals new Objo Tokenizer. Okay. Great. So let's go back to our tokenize button. So what we want to do is we want to have an array of tokens that the window has. Yes, we're going to need that as a property, aren't we? So let's just add that. Option Command P for a new property. We'll type tokens. It's an array of type Objo tokens. And when we click the tokenize button, the first thing we'll do is clear the tokens list box. Okay, so we will do listbox tokens dot remove all rows, and we will reset the tokenizer. Reset. Remember our reset function we wrote? So I'm going to reset it all so it's ready to go. Then we will tell it to tokenize what's in the source code text area. So we will just do my tokens equals, oops. Do you know what? I shouldn't really use self all the time. I don't need to. It's just extra words, isn't it? It's just sloppy. So tokenizer.tokenize source code text. So that ought to work. And let's just put a break there and see if we've done that right. So we're going to run it. Compiles, that's good. So let's do var s equals hello world. I already see a problem here. Watch this. Tokenize. Error. Yep. So we've raised an error. We've been dropped into our error method. If we click on the message, we get unexpected character. Now it looks like a double quote. You might not be able to see this in the video, but it's not. It's a smart quote, which is really annoying. macOS helpfully, or the text area, helpfully inserts these smart double quotes when you type double quotes around characters, okay, because they look pretty. You know, the ones which angle slightly left or slightly right. We don't want that in programming, okay? We wanted to leave it alone, which is annoying. We could just keep doing Command Z to undo it, but I do have a project somewhere that gets around that. Let me see if I can dig out where it is. It is trying to think what it's called. I think it's called source code area. Yeah, where's that? Yeah, that's the stuff. That's the one. Where is it? I'll find it. UI controls. In a project called Possum I had. Okay, fine. I can find that. Let's just open that up. Should have done this before already, shouldn't I? Hang on. UI controls, source code area. So I'm going to copy that. Don't need this project anymore. Paste it in. Okay, this will be in the GitHub repo, so don't worry about it. It's basically a text area subclass, but in it, I've got a couple of methods for setting smart quotes and setting smart dashes. And basically what they do is use some declares to stop that behavior. All right. All that we need to do is in window 1, change this text area into a source code area, and that should be it. Oh no, one other thing we need to do is when the window opens, we need to do source code dot smart dashes equals false, and let's turn off the other one as well, smart quotes equal false. Okay, so that's just to stop the Mac automatically converting it, which we don't want. Okay, so let's run it. Hopefully this will work. So we'll do var s equals hello world. Great, it's not changed it, it is working. So tokenize. Yes, no error. So what do the tokens look like? So we'll go into the window and we'll find the tokens. Here we go. So here's the debugger. And I don't know if you knew this, but you can change, when you've got an array of instances of a class that have different properties, in the debugger you can actually change what's shown. So these are tokens, so I can show the lexeme, the start position, the type. Let's have a look at the lexeme. So we've got, let's look at the type actually first. The string we typed in has come back with 6 tokens. A var token, an identifier, equals, a string literal, then the end of line, then the end of file. That's looking pretty good to me. Okay, so let's make that a little bit easier to inspect rather than going into the debugger. So let's get rid of that break. I think we probably want to have a, we'll come to error handling in a minute actually. Let's take those tokens, we'll assume it's successfully tokenized them, and we'll take those tokens and we'll throw them into a method, and that method's job is to display them in the token box. So actually what we can first do is get rid of this remove all rows thing, because we'll have our method do that. So we'll just do display tokens. Okay, so let's create a method, and what that will do is it will first of all clear the list box. Then what we need to do is iterate through every token in our tokens array and put them into the list box. So that's easy enough. We'll do for each token as Objo token in tokens. Next token. Now what we want to do is we need to know the column, which column in the list box represents which property. Now we could just remember what we wrote, but that's bad programming. Okay, we should have constants declared that help us to remember what the column number is for the different properties. So we'll put that constant on the window. So I'm going to do Option Command C for a new constant, and I'm going to do column line, which was number 0. I'm going to do column start, which is column 1. Column what was next? It was type, which is column 2. Remember, it's 0 based. And finally, it was column lexeme, which is column 3. Get rid of these random constants. Okay, so now in our display token thing, we know the column numbers. So we'll say, okay, well, what's first? The line number, easy. The line number is an integer. So we'll say, oh, actually, no, for each token, we need to add a blank line to the list box. Okay, so we'll do list box tokens dot add an empty row. Okay, this is what I find the easiest way of doing multi-column list boxes. Add an empty row. Then we will get the index in the list box of that row we've just added. This is just going to simplify the code a little bit. Actually, no, let's not even simplify things, Gary. Let's just write the properties in. So in column 0, or in the line column, we want to write the line. So we'll do list box tokens cell value at. Okay, so this is how you set the value of a cell. and it takes two properties, the row, and so the row will be whatever the last index was. Okay, the last one we added. So that is listbox tokens last added row index. Now you can see this is going to end up being really long and boilerplatey. So what I'm going to do is I'm going to take that and store it. Store the index. Var index as integer equals that. And now we can just say, okay, in the listbox tokens, which row? Well, actually, call it row. That's even easier. Store the row. So now we add to row that we just got the index for and the column. Well, which column is the line in? Well, it's in column line. So what do we want it to be? Well, we want it to be the line number of the token. Now that won't work because line number is an integer and it's going to say you need to add a string. So we can just do toString. Okay, we'll do the same for token start position. We're just going to copy that because it's almost the same code, except this is column start and this is token start position. Just make that so you can see that. Let's get rid of that. And next up is the token type. Slightly difficult. Remember, the token type is an enumeration, so it's an integer, but it doesn't have a string representation. Now that will be a bit naff, really, for us in the list box. So let's fix that by adding a, how should we do this? We can add an extension method to the Objo module that will let the enumeration turn itself into a string. Actually, that's a really good thing to learn, isn't it? Let's do that. So we'll go to the Objo module where the enumerations are defined. Here's the token type enumerations. All of these. Oh man, this is going to be a bit boring to write, but okay, it's just grunt work here. Maybe I'll scratch through this when I edit the video. Right, so, but anyway, let's get started. So we're going to add a method on the Objo module, and we're going to call it toString. Okay, and it's going to extends type as Objo token types, and it's going to return a string. And we will make it global, so it's accessible everywhere. Now let's just analyze our project with Command K. To make sure that is allowed. Yeah, cool, it is. So now what we need to do is just do a select case. So we select the type that's passed and we return a string. So we'll do case Objo token types. We've got all these to go through. Okay, so we can speed this up a little bit. Okay, oh my lord, right. The magic of video editing, you didn't have to see me write all of that. So that's all. One more thing to add is if it's not one of those things, then we will throw an error, okay? Because it probably means we've added a token down the line and we forgot to come back here and do it. So we'll just do raise new unsupported. Oh no, not raise new invalid argument exception. And we'll say unknown token type. Cool. So now for each of these types, we need to return the string version of it. So ampersand. Okay, we're just going to do return ampersand. Okay. For this one, it's going to be return binary literal, etc. I'm going to edit this. Do it all, we'll come back, okay? Okay, right. Let's just do an analyze, make sure I've not made an error. Great. So just to recap, basically now what we can do is we can call a toString method on a token type enumeration and we'll get back a string representation of it. Oh man, that was dull. Right, so let's go back to our display tokens. So Right, we want to make the token type column equal its type to string. Boom. Okay, as easy as that. Now we'll get a nice human readable version of that token type. And finally, we want the token lexeme. Now remember, this sometimes isn't a lexeme, it's empty, but that's fine. And we will just do the lexeme column equals the lexeme. Now I think that's it. Let's see, shall we just check it compiles? It does. Just run it. So we'll type the same thing, var s equals hello world, and then we'll do tokenize. Yay, didn't crash, and we don't need to use the debugger anymore. So we can see they're all on line 1. We can also see the start position. So var starts at position 0. The identifier, which is s, yay, starts at 1, 2, 3, 0, 1, 2, 3, 4, position 4, correct. Then we have an equals type. Note there's no lexeme. A string literal, which is hello world. An end of line token, because it's the end of a line. And then the end of file. Let's add another line. How about we just do 100 plus 65.7 tokenize. We've got the same ones, but then now on line 2, we have a number, and it's number 100. Then a plus sign, then another number, which is 65.7, end of line, end of file. Okay, we can keep going as much as we want. Notice that this isn't checking anything apart from the tokens. Okay, if I write garbage like I don't know, like that, that's going to be tokenized. Okay, no errors. Right? They're still tokens. They don't make syntactical sense for Objo, but they are valid tokens. Just check they worked out right. We've got an identifier, another one called S, correct. A number which is 9E0. Binary literal, cool. Let's try our funny strings. So let's just try an empty string. String literal that's empty, cool. Let's put a quote in. Now this should break. Yes, it does. And it breaks with the message unterminated string literal, expected a closing double quote. Absolutely it did, okay? Because we just put a double quote inside 2 double quotes. Now if we keep running, it's going to crash it. So we're not handling the tokenizer failing. So that's no good. So we need to put a bit of logic in there. So if we go back to the tokenize button, we need to add an exception handler. So let's do exception E as Objo tokenizer exception. In fact, we'll put this in a try block. Try doing that, and catch E as Objo tokenizer exception and try. And so what this is doing is it's trying to tokenize the source code, and if it does, it's great. It displays the tokens. If it fails, we'll do something, but no matter what happens, we always, actually no, let's get rid of that. What we'll do is, if it fails, we will still remove all the rows from the tokenizer, from the token box. We need to display some sort of message that stops us crashing into the debugger. So let's go back to the window, and let's put maybe down here, we'll get a text. No, we'll get a label. How about we get a label? We put that there, and how about we just give it a little bit more space. Let's make it a little bit bigger. Oops, I meant to make it taller, not. Let's put that there, and we'll make it multi-line. and we'll let it stretch right the way over here, and we'll lock it in those positions, and we'll just call it info. And anything else we want to do? Text align. Yeah, okay, fine. So we'll just put the word info in there, and we'll put the error message in there when it happens. So we go back to the tokenizer button. If we encounter an Objo tokenizer exception, then we need to make an error message. Okay, so what we'll do is we will do. Well, actually, firstly, if it works, let's make info text equal tokenized successfully. Okay. Otherwise, we will make info text equal the error message. For some reason, in try catch blocks, Objo really struggles to autocomplete. But anyway, we'll make it the error message. And that should work now. So if we run that, let's do something nonsensical. Tokenize. Annoying. We're still dropping into the debugger. Now, why are we dropping into the debugger? Well, it's because, I'll show you why. There's a project setting that says break on exceptions. If you uncheck that, then the app will just crash if the exception isn't handled. So ours won't crash if I uncheck that, but I like keeping it on when I'm debugging. But what I can do is I can force IDE to not drop into the debugger if an exception is raised in a particular method. And I can do that with a pragma. So I'm going to go into the error, Objo tokenizer, into the error message, okay? And I'm going to say, I'm going to do pragma, which is like a message to the compiler, and say pragma break on exceptions false. Okay, so what that will do is for this method only, if an exception is being raised, don't drop into the debugger. Okay, no matter what my project setting says. So hopefully now when we type these three and tokenize, it doesn't crash into the debugger. It will still go into the debugger if an exception occurs, just not in that method. And you can see down here, unterminated string literal, expected a double closing quote. Hooray. So we can make that a bit better, actually, that message. Why don't we say, instead of just putting the message, we can say the info text equals the message. Maybe we'll want to say the line number and where on the line the error occurred. So why don't we say, we'll put the message, actually, well, how about we have it in maybe some little square brackets, the line number and then the position and then a colon and then the message. Something like this. We'll do an open bracket and we'll do error dot. That's frustrating. I've got autocomplete. So if we do as Objo tokenizer exception equals E, this will just help us with auto completion. Dot. We want the line number plus the line character position, like so. Okay, and a colon, and the error message. Cool. And now I know what the actual properties are. I'm just going to delete that. So if there's an error, make the text box be some square brackets with the line number and the character position and then the message. Let's try that. Oops. Unexpected literal begotten integer. Oh, because this is an integer and needs to be a string. So does this. Okay, let's try that. Tokenize. Line 1, character position 2. Unterminated string literal. Perfect. Okay, we'll just try escaping it with 2 quotes, and it works perfectly. Hooray! Okay, and we'll do. I think that's enough for you to experiment and play around with. So it's working. Okay, our tokenizer is working. Hooray! So next up is starting with the parser. So this is obviously on GitHub. The commit at this point will be referenced in the commit for this point will be the video title, so you can find it in the repository history. But please explore it. If you find a bug, let me know and we'll fix it. But next up, we're going to be doing the parser. Have fun.